It's worth trying to figure out what the running time is asymptotically, big theta, for selection and insertion as a function of n and k, and then we can substitute in the value of k. So if there's n elements in our list and we're interested in the top k, what the selection algorithm does is it goes through the elements one at a time, and for each of these n elements, it tries to figure out where in this list of k it needs to go. So for each of these n, it does an insertion or a selection. Okay, let's do insertion first. It does an insertion in this list. That insertion takes big O of k time. It's basically running through this list, figuring out where the value goes, sticking it in, and shifting everything else over. The insertion algorithm is going to take n times that, or a total of big theta of n times k. Now, selection is the same. What happens in selection is you run through this list of n, and you pull out the maximum and delete. So that takes big theta of n time, and you repeat that once for each of the elements that you want to pull out. So it becomes also big theta of n times k. Sorting, on the other hand, sorts this entire list, which I said before was n log n. Then, well, it's kind of done at that point, but you could imagine also looping back through the first k elements. But we basically have them at that point, and k is smaller than n. So asymptotically, that's the whole running time. Now, if k is n over 2, that's n times n over 2, or n squared. This is big theta of n squared. This is big theta of n log n. We're much better with n log n. So if it's a very long list that we're wanting the top values of, you might as well just sort the whole thing. Square root of n, well, what happens with square root of n? Square root of n, we're comparing n log n to n times the square root of n, which is n to the 3/2. N to the 3/2 is asymptotically larger than n log n, so we're still better off just sorting the whole list. Let's go to the other side of the spectrum. What if there's 100 elements in the list? Well, if k is a constant, k is 100, then the big theta of this is just big theta of n. It's linear time. So linear beats n log n. So definitely want to choose these algorithms over sorting if it's a small number of elements that you want to know. Log n is similar. We end up with n times log n, which is better than n log n. And finally, and this I guess should be kind of obvious at this point, if we substitute log n in for k, we have n log n for selection and insertion, but we also have n log n for sorting. So these are actually the same.